Welcome guys, this is P Madhan Mohan coming to you from Jasmine Infotech. In the first part, we have seen what is the signal ambiguity that present in the frequency domain, which mandates the sampling theorem. And in the second part, we have seen why the spectrum is repeating, which shows what is the maximum frequency component in the input signal that we can represent in the spectrum without any problem. Before workout on the sampling theorem, let's see what a composite signal is. Composite signal is an addition of so many sinusoidal components. We have previously seen very simple sinusoids, and here an example is given for the composite signal. There are three components: 1 kHz, 4 kHz and 8 kHz. The maximum frequency component is 8 kHz. Already we have seen the restriction of the frequency domain, that is spectrum minus fs by 2 to plus fs by 2 is repeating from fs by 2 to infinity and from minus fs by 2 to minus infinity. The faithful spectrum is from minus fs by 2 to plus fs by 2, and that is the spectrum of our interest. All we need to have is to put all our frequency components of the composite signal in the faithful spectrum. We know the maximum frequency component of the composite signal, that is f max. So all the frequency components of the composite signal could be placed inside the faithful spectrum only when the maximum frequency component in the composite signal must be less than or equal to fs by 2. So this is the spectrum of interest, and f0 and f1 are components of the composite signal, and f max is the maximum frequency component that must lie exactly on the fs by 2 or maybe below that. This leads to the condition shown in the next slide. F max is less than or equal to fs by 2, then it becomes fs is greater than or equal to 2 max. The sampling rate must be at least 2 times the highest frequency component contained in the signal, and the minimum required sampling rate, that is fs is equal to 2f max, is called Nyquist rate. Okay, now the sampling theorem is clear. The sampling frequency must be at least 2 times the highest frequency component contained in the input signal. If we violate this, what will happen? That is our next topic. Okay friends, if you have any comments and suggestions, please send it to the email ID pmadhan.edu@gmail.com. This is P Madhan Mohan for Power DSP Lessons. Meet you again. Until then, bye bye.